Okay, so we're going to continue here, and we can see that the we prepare the parcel data. We search for the suitable park sites. It's limited to vacant land parcels. As we saw here, vacancy is an attribute of the standalone non-spatial vacant parcels table. We must associate this attribute with the parcels feature class so that we can see and select vacant parcels on the map. We will do this with an operation called a table join. So table join is very easy, and we're going to do that. And a table join attaches the attributes of one table, usually a non-spatial standalone table, to choose of another, usually a feature class attribute table. So the join is based on a field of values, typically an identification code, which is common to both tables. So values in the common field are used to match records in the standalone table with records in the feature attribute table. So here we will learn the joins and relates more here. And I know this section we have to talk about field data, dissolving features, and how to look at a lot of things, but we still have to find chances to do that. And now we're going to add data. First, we will add the parcel and vacant parcel to the map. So I don't want to start a new one, so I'm gonna use the current one. So now under contents, right now we are preparing for the parcel. So serving the most people, I think land parcel and vacant data. So while doing here now, we have to do join table at this point. I'm gonna close everything out. So under table of contents, we will turn all the layer except Los Angeles River. So I'm gonna see Los Angeles River. There. So this is Los Angeles River, and we leave the county. Okay, so if this is the county, that's fine. And the city, yeah, I can have the city. I don't need the topographic map. We're going to expand the folder. Gonna do. Oh, how do I have all the county? That's fine then. Close this out. I don't need to show this. Okay, so we expand the folder project pan and project pan. So to do that, now here I called project pan and browse to source data and city. We have to go back to view catalog pan. Catalog pan folders and expand everything each time. So here we will go to City of Los Angeles. Now we have a parcel. So the parcel, I don't see it. So I'm gonna zoom to layer right here. We add the parcel shapefile, and we need the vacant parcel base file. I should add it here, and I'm gonna look at it. What kind of data is here? Parcel. I'm gonna open attribute table. Okay. Use code parcel, use code city, use code. So I think the thing is just use code is the common field that we can join together. So because vacant parcel base file is simply a table and not a layer with vector features stored with it. So the table is added to the standalone table group in the contents pane, and we will zoom to the parcel layer. Now we can identify the common attribute. We will look at both tables to find the common attribute or key field. So we open the parcels attribute table and then the vacant parcels table. So now vacant parcels table, we could do is put it side by side there. So I'm gonna drag it here. So that's pro. You have the function, you can view table at the same time. That's really nice that you can put side by side, and I have a bigger screen and it's really nice for me. But the ArcMap, you do not have that feature. So at the top of the window so right here, I was click on and I drag it until we see the tab blue docking target on the right. So, and then in the puzzle table and the vacant puzzle table on the right, note that we both display an accessor identification number. So, accessor identification number AIN. So AIN, so AIN, the attribute. AIN is a unique identifier. In theory, when we join the tables, each of the 29,461 records in the vacant puzzles table should find a single matching record in the puzzles table. So we will have to do join and relates later, but now I just showed you how to do it, and then we will come back to do joins and relates. We will talk about it, and I will make it up there for you. So join tables, we do not need to have the tables open to join them. So now we will close the two windows. Under Contents, right-click the puzzle layer and click Join and Relates, and we will go to Join. So right-click on here, we say Join and Relates, Add Join. So when I add join, the geoprocessing pane opens with Add Join to displayed, and we will confirm that the layer is set as the layer name parameter and vacant puzzle. So it will be AIM, vacant puzzles, AIM, a join table. And in the input join drop down list, we will click AIM. It will automatically set it for me, and this specifies the key field in the puzzles table. When we select the input join field, ArcGIS, so ArcGIS Pro will automatically look for the field with a matching name in the join table. Because we have an AIM field in both the input and a join layer, AIN is matched for us as the output join field, and confirm that AIM is selected for output join field. We confirm that drop down list number 2 for join table is set to vacant puzzles, and then I'll just click run. We click the keep all target features checkbox on. So oh no, I should clear it. So now clear it, and I'm gonna run it again. Alright, run. I think it's still running. We have to clear this keep all targets features. So now I'm gonna wait a little bit and see what's going on. And now we can see things added there. The only puzzles that interest us are the vacant ones, with those matches in the vacant puzzle table. If this box is checked, the layer will have all the puzzles with null values for all records that cannot be matched. Now we're going to compare the tool to the finger and click run. When the so I have here puzzle, I have here vacant puzzles, AIM. I'm gonna click run again then. So compare the tool, and here when the tool is finished running, the puzzle layer redraws on the map because we chose to keep only the matching records, and vacant puzzles are the only ones that draw. Okay, we do have some null values here. Open the attribute table of the puzzles layer. So I do have it here. I'm gonna drag this to the right and see here. And then we have the attribute, and we examine the attribute field. The join table has the attribute of both tables. It has 29,461 joined records, which means that all the records from the vacant puzzles table will match to the puzzles layer. Now we go to copy features. So it is important to understand that a join does not actually save the new fields to the input feature class. The join is maintained virtually for only this layer in this particular map. We will now create a new feature class in the project geodatabase, copying just the vacant puzzle features from the joined table. So we're going to open open the copy feature tool. So open copy feature tool, go back to analysis. No, tools, and copy feature tools is right here. And in the copy feature dialog box, we will set the input features to the puzzles layer. So input feature to puzzles layer. And then we will have a vacant, I will type vacant puzzles join. Click run. Now vacant puzzles join, and now we have is when the tool is finished running, the new feature class appears in the project geodatabase, and a layer is added to the map. So under the contents, which is right here, under the contents, we will remove the puzzles layer and the vacant puzzles table. I'm gonna remove this, and then where is the join? Okay, I removed it, and vacant puzzles table, remove. Okay, then I'm gonna refresh my geodatabase. Going to refresh. Copy feature, vacant puzzles join. Okay, add it here. Let me double check with the attribute table. Yeah, everything is here. Cannot acquire the data. I think something wrong is here, so I might have to rejoin everything. Oh, it is here. Let me see, open attribute table. There, finally it showed up. So although we have a lot of null value, let's rank it a little bit. It's a lot of data here. We'll just give a lot of time. I'm gonna just slow. Descending. There. So you can see all those data here. Perfect. And the virtual attributes of the join table are now permanent attributes of the new field class. So field names from the two original tables in the join have been converted to an alias in this table already. And using the menu button, we can turn off the alias to see the complete field name that indicates with an underscore with source table the attribute that it came from. So I can just say show field alias. I already have it. And then I can say show all fields. Okay, so now if I hover on top, so there we can see vacant puzzle and vacant puzzle ID. Alright. And then dissolve vacant puzzles. That's what we're gonna do. Now here we must still calculate acreage of the vacant puzzles, row 3 of the data requirement table. At this point, we might have a new thought. What if there are some adjacent vacant puzzles that are smaller than a quarter acre individually, but would be more than a quarter acre if combined? We might be missing out on some potential park sites simply because of property lines. So to address this possibility, we would dissolve the vacant puzzles join feature class, which will create single features out of puzzles sharing a common boundary. So in the process, we are going to lose attributes. If we do not really need the attributes though, at least we don't need them as much as we need good park locations. So what we're going to do, we're going to dissolve again. So I'm gonna leave this and I'm gonna find my dissolve tool. So for dissolve, I'm gonna move in the middle, input feature. So input feature will be the vacant puzzle join. And output, I would say just vacant puzzles. Vacant puzzles. Vacant puzzles. Vacant puzzles. So leave the dissolve field as blank. And we are dissolving purely on the puzzle geometry. So dissolving features here. At the bottom of the dialog box, we will click to clear the create multiple features. And if we allow multiple features, the output feature class would consist of a single multi-part polygon. We would have one great big continuous vacant puzzle. So now we compare the two here and we're gonna run. So everything leave it blank. We just have to put input and output name and click run. Uncheck this, always remember. And now under contents pane, once the dissolve is completed, vacant puzzle will be added to the project geodatabase and the layer is added to the map. So we're gonna just wait. And we can see how here it's gonna change. Dissolving. And under contents, we will remove the puzzles join. So wait until it's done, and then we will open the attribute table, which is right here. No, not right here. It will be a new one. And then we can compare. Okay, it has 14,269 records. So about half as many as the dissolved layer. So now it's done. So I'm gonna turn it off, and this is the attribute table. Oh, just wait a little bit, and I think the reason is it was still generating there. So now it dissolved. Let's see. There. If we compare, I think something wrong here with my data now. It has something to do with the join. So my join wasn't something wrong with my join. Let's see. We added a join. So I didn't keep all the records. So I think I have to redo it again for the join and everything. Sorry, that it happens. So I have to rename everything. Okay, we will start from the join. Okay, and first we will have to redo it. That happens. It's okay. Okay, I need this table. Oh, remember, and then we need the puzzle. Puzzles there. So we need the puzzles. Yeah, puzzles, and then we need to add the join. Did I add the puzzles? Where did the puzzle go? There. So right click on it and joins and relates, add join. So puzzles, input join, and not this table. It's the puzzle, vacant puzzles. Very good. Okay, I don't want to keep all the targets feature. Gonna run, and then I have to look again. So let's double check. Okay. Load all. It will be 29,461 records total. Let's just wait a little bit. Okay. Yep. Last time I added everything because when we add the puzzle, let me just move the puzzle back. So remember the puzzle attribute table, and let me open this puzzle again. Let me explain again. So this is 29,461 records, and the puzzle is 79,000 795,568. So once we join, we will have a last record that it will be everything is from this one. So however, this is just a part-time kind of temple join. So let me open this. That's this one. All right. So this puzzles, open attribute table. Let's see, attribute table. So that's the one I cannot save it. So I'm gonna just do data, go to data, export feature. So just export this feature. So I will just say the one we have to export it, that it is called, it's temporary, and we add a join, we copy feature, vacant puzzles join. Yep. Vacant puzzles join. I'll just say 2 then. Alright, so that I have the 2, then I dissolve. When I dissolve, and I have to rename it vacant puzzles 2. I will do vacant puzzles 2. Okay, it's almost done. Okay, now that's the one I want. I'm gonna open attribute table. So see 29,461, and now I'm gonna do is bring back tools and dissolve. So I'm gonna put is 2 and I'll just say vacant puzzle dissolve. Okay, I like this, and check this and run. So then we should have a 14,226. So this is the dissolve one. There, 269 records, about half as many as the undissolved layer, and the only attributes present are the 4 managed by the ArcGIS Pro. So now we're going to calculate the acreage. To calculate a field, it's very easy. That we're gonna do is now we can get back to the acreage. So ArcGIS Pro has recalculated the shape area field for the dissolved puzzles, but the units are in the units of the map projection. We need to convert them to acres. So today I review a lot of acres stuff. So now I'm gonna do is add a field to the vacant puzzle table. So vacant puzzle table. So I'm gonna go to fields view and add a table that I will have is acres, and then alias it will be acres, and for the data type it will be double. Okay, double, and then I'm gonna click save. There. So now we are ready. Gonna close it out, and I'm gonna acreage and calculate field. So calculate field, back in the table, right click the acres field heading and click calculate field, and we're going to type the following text in the text box under the acreage, so that I will have exclamation mark. I will have a shape dot area at acres. So acres and exclamation mark, and we will compare the tool here. I'm gonna run. So now ArcGIS Pro will calculate the acreage for each record and adds the values to the table. So here we have everything, and 22696 1247. Okay, perfect. 145A97. Under the summary statistic tool, to calculate the total sum of the vacant puzzles in acres and average size, name the output table parameter vacant puzzle acres sum mean. So now I'm gonna close this out and go to tools, and then summary statistics. So input table will be puzzles dissolve, and output table that I'm gonna put is vacant puzzles, acres sum mean. That's the naming method I like to use. And then field that I will have acres. Field will be acres. Field will have acres. The first one is sum. The second one is mean. And case field, nothing. Just click to run. And once we have a table down here, and go to open, so then we should have close to 17,244.6 total and 1.2 acres. Now we're going to close all table. Yay! Alright. So now I'm gonna close everything. Perfect. So we will clean up the project geodatabase. So we will get rid of the unsolved vacant puzzles join, and then we will add the item description for this vacant puzzles feature class. So in the project pane, in the project geodatabase, we will right click on the vacant puzzles join. And then I'm gonna delete and make sure the vacant puzzles join not vacant puzzles. So okay, and then yes, click, and I don't need the vacant puzzle joins to neither. Okay, and on the prompt, click yes to confirm the deletion. The feature class is deleted from the geodatabase. In the project pane, and we will right click on the vacant puzzle feature class and click view metadata. So I'm gonna click vacant data, vacant puzzle. I think something wrong with my vacant puzzles. Vacant puzzles dissolve. Alright. So this one is my correct one. And I'm gonna go view metadata. So view first. Click view metadata except for the title, which reflects the feature class name and the file format type at the top. So the item description is empty. So on the home, so here on home here it will be added, so that I can add it, the metadata group. In the title box, we will change the title to vacant puzzle. So vacant puzzle. And then we will scroll down and click. I dissolve. I think I'm gonna leave it. I like it dissolve, so I know it's the final one that I dissolve it. And click the title box, vacant puzzle with a space. Scroll down and click the text. So the text I will say puzzles and vacant puzzles, and then Los Angeles. So include the commas, they separate tags. So I'm gonna scroll down if necessary, and in the summary box right here, and I will say this data set of land puzzles in the city of Los Angeles supports queries on the size of contiguous vacant puzzles. And then we will click the description box, which is right here, and type this data set represents 29,461 original vacant puzzles in the city of Los Angeles. Adjacent puzzles have been dissolved, and then leaving 14,269 features. Okay, we have everything, and now I'm gonna just click save. And on the matter ribbon in the data manage metadata group, we will click the save button, which is right here. I click save, 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 save. Will it save? Save, save. It should grayed out for me. That's weird. And we will close the tab and everything, and confirm that the project geodatabase feature class shown here, and I'm gonna save. There, so I'll close it out. And for the geodatabase, I'm gonna double check with the data because I have a lot of data that I need to clean it up. Block centroids, yeah, block centroid, okay, and block groups and block group statistic check. And I need cities, I need counties, and counties copy features. So let's see which one I need. Okay. Zoom to layer. Okay, so copy features. So let's see about this one. Alright. Counties. Zoom to layer. Oh, I don't need this then. So I'm gonna remove it from here and delete it from here. There. So, and then I have to rename my county zoom to layer. So this will be our counties, okay. And then Los Angeles River, dissolve. Then I'll just say Los Angeles River. Okay, Los Angeles statistics. I don't need this. Delete. Okay, delete. And I don't need a line. I need line 1. Delete. So I just change the name to line bright. Okay, and for parks, we do have a parks, and then point bright. Remove this, and I need point bright. Polygon, I don't need polygon. I need point bright and then polygon bright. Rename and polygon bright. River, I don't need the river. River copy features, nope. So I have to see the river copy features. So let's see. Let me zoom to layer. Rivers, zoom to layer. There. It's the same with Los Angeles River, I think. Let's see. I cannot see the river. Zoom to layer. There. Zoom to layer. Let's see. Zoom to layer. Okay, this one is not projected, so I'm gonna delete it. So, okay, and then polygon bright and vacant puzzles. Okay, and vacant the sum and okay, I don't need the vacant puzzle dissolve. Vacant puzzle dissolve. Oh, I do need this vacant puzzle dissolve. Okay, so that's all. Everything I'm gonna save it here. Okay, and we're going to move on. Now we're going to add the data. So data integrity is crucial in GIS. And ArcGIS Pro has some built-in safeguards to make sure we really mean to be doing what we are doing. When editing, if we make a mistake, we can recover with the undo button, which lets us to undo edit one by one in reverse order. If the mistakes are too complicated to resolve, we can discard the edits without saving them. Ideally, data will come to us free of errors or consistency, but that seldom happens. Careful exploration of data usually reveals imperfection, which arise from all kinds of reasons. Sometimes data is captured or created incorrectly to begin with. Sometimes errors creep in with subsequent data processing. Sometimes the data is perfectly good until the world changes. And sometimes the data isn't wrong at all. It's just generalized for use at a certain scale and inappropriate for use at other scale. For example, the park data we are using was really designated for median scale maps, more or less in the range of 1 to 100,000 to 250,000. When the features are examined at much larger scale, it is not surprising that they do not conform to high-resolution imagery. ArcGIS Pro has many tools for editing features in specialized ways, as well as methods for evaluating and maintaining data integrity. Data editing, however, isn't the focus on the project. We are correcting one park feature and creating another because during the data exploration we saw a need to do so, and then we will move ahead with the analysis. So now we're going to edit a feature. So we saw the Pecan Playground, a park near Dodger Stadium, didn't match up well against the imagery. So here we will edit the park boundary and update its acreage attribute. So here we're going to start a new map. So I know here we have a lot of layers here. So I'm gonna go to maps, right click on it, and I will just say new map, and then I'm gonna rename it. So lesson 5, just editing. Okay, we will change the map. Go back to our contents. So the base map, we will say imagery, so I can see things. In the project pane, we will navigate to the Los Angeles River project and geodatabase in the database folder. And from the Los Angeles River Park site geodatabase, we will drag parks to the map. If necessary, then we will click the parks layer and click zoom to layer. So parks, geodatabase, finally we can use our data. So, and then we're gonna say zoom to layer, and now we can see everything. And zoom to Pecan Playground and add it. Now we're going to zoom to the Pecan Playground bookmark. So then we will do the bookmark, and now I'm going to open the symbology pane for the layer, and we will change the fill into no color. So I will just say no color, but then in this case we cannot see. We will do is not here. We'll just say symbology. Click this and go to property, and this one I'm gonna do yellow or green. So here we will do is quasar green. Quasar green. This one. And the thickness we will apply it to 2. Click apply. And now zoom and pan and edit. We see the whole bookmark in the figure here, and then the feature here we see it doesn't include the swimming pool, so we might have to drag it so that it will include the swimming pool. And there is if I'm zooming, there is a playground here. See, you see the houses and stuff. So that means the feature was drawn doesn't include the swimming pool or the play area at the north end of the block. Also, its boundary extend into the street. So right here, this side. So I'm gonna move it a little back here. And the southwest corner of the block is correctly excluded at this. This is a school. After editing, then the Pecan Playground should look more like the modified version. So base map layer are updated periodically, so the imagery may look different. It's not huge different, but it is. Here we are missing some trees in this area. I can tell, and there are some cars here. Yeah, it's a little different. But the swimming pool is here, the trees here, the trees are here, and not a lot of shade. And don't worry too much about here. We should be fairly easy to make the feature better than it is now, and that is good enough. So now on the Edit toolbar, so we're going to go is Edit and click the Select button. I'm gonna do Select. I'm gonna select this and click anywhere inside the Pecan Playground feature to select it. The feature outline turns bright blue momentary. We confirm that snapping is turned on, so I need snapping. Yeah, snapping is turned on. So snapping, if it's shade, it's turned on. And the snapping tool on the edit bar should be blue if it's on. So if not, it's selected to turn it on. And we will click the Modify button in the feature group. The Modify feature pane opens. Under Reshape, so I'm gonna do is Tool. Under Reshape, click the Vertices tool. So right here. Okay, vertices. So vertices, and then two things happen. One is that the new tool is right here. Everything is here. Added vertices. The two things happen. So one is that a new toolbar in the Added Vertices toolbar is added, and the other is that the feature is now marked with a number of small green squares. So now I'm gonna move this. So that vertices, the other thing that the feature now marked with a number of small green squares, which is right here. So I'm gonna drag it here and then drag this here. So I double click on it, then it changes. So number 6, I'm gonna move it to here, and this one move it here. 3, 2 is fine, and move it a little bit down, not on the street. And this one, move it back here, move it here, and that's it. And you double click on it, and now heads up digitizing, it's finished. So let's see. The other one here, vertices, we collect the vertices or coordinate pairs that define the feature's shape and position. The red vertices is the last one added when the feature was created or added it. In the figure thought not on the screen, the vertices are numbered or not referenced. Note that the red circles with numbers will not appear here, of course, for sure. And they are not visual instructions only, so you just go there and, oh, perfect. And every now and then it will just, oh, do you want to save your edits? So as we edit the feature, we may find it useful to zoom and pan using shortcut keys. So the shortcut keys for navigating while editing. To navigate while editing vertices, use the shortcut key Z to zoom in, and X to zoom out, and C to pan, B for zoom, pan, click, and drag to zoom, click, and drag, pan, click. The clicking tools such as Explore, Interruption, Vertex Editing. If we accidentally interrupt vertex editing, click the Vertices button on the Modify feature pane and to resume it. And now, on the Added Vertices toolbar, we will make sure the normal tool is selected. So this is this one. And place the pointer over Vertex 2, which is right here. And then I'm going to drag it out a little bit. So, which is street intersection. When the pointer is directly over the vertex, exchange it to a four-headed, right here, four-headed arrow. And we will click and drag the vertex where it should go, the northeastern corner of the soccer field, and then release the mouse button. If we make mistake, we can just recover with the undo button. So, undo button, that is Where is undo button? I'm still looking. Undo button. I think maybe I have to go back to map. Undo button, nope. Go back. View, alright. So go back to edit. I don't find the undo button. Access toolbar. So where is the access toolbar? Gonna close this out. Status edit. I don't see, but we could. I don't have it now. I don't think it has it here. I don't see it anywhere. Okay, so you do not have a save until. So now the blue highlight continues to show the original shape of the feature. So now we will place the pointer over vertex 0 and move the vertex to the northeastern corner of the park. So I'm gonna move it down a little bit like this. Okay, and then the eastern button now has a kink because of vertex 1. So this vertex is superfluous. And on the added vertex toolbar, we will click the delete tool. So delete tool, and then click vertex 1 to delete the vertex cell, which is, I think it is right here. And I delete it. Oh my god. So nope. So I'm gonna drag this back. Okay, add a okay. I'm still gonna go to vertexes. And then I say just discard. There. So and click delete vertex to 1 in here. So I don't want this vertex, so I'm going to select on it and then gonna delete this. Yes. Okay, vertices. I still have this vertex. I don't see where is 1. Oh, right here. So this one. Okay, I already deleted it. So it just takes a while. You have to be careful. And I delete that point. And on the added vertices, click the normal tool and move vertices 7 and vertices 7, which is right here. And I already moved it. So now I'm gonna move the 5 park vertices. So I can move this too and move this a little here. Yeah, save it. And double click on it and then just wait a little bit. And this thing I can move it a little bit and double click on it. Okay. So on the added vertices toolbar, and click the normal tool and move vertices 7 and the red vertex to the northeast corner of the park. And we will move vertex 5 to where the baseball diamond meets the schoolyard. And we will click the delete tool and delete vertex 6. So right here, I'm gonna select on it, and is this select on it? It should be in red color or some color. Then I don't want this vertex. Delete. There, it's deleted. So you don't see. It's just so slow. Now I'm gonna save it. Click yes. And I don't have the vertices here. So and now we click the delete tool, and we deleted the vertex 6 to the straight west channel of the park, which is right here. We deleted 2. It just so it just take a while. And click the normal tool and move vertex 3 to the northeastern. So which is right here. I can move like this a little bit. And this, I can just move it. Yep. And it's a little too much. Okay, we move the vertex 3 to the southwestern corner of the circle field. And we will continue explore snapping. When we move a vertex, when we move the vertex, so that we could do here is snapping when we move a vertex near another. Oh, it asked me to save again. Go to click yes, save again. When we move a vertex near another feature, the vertex connects to it automatically. So this behavior called snapping. So the snapping helps prevent errors such as small gaps and overshoots. So a vertex will snap to features in its own layer as well as features in other layers. We may have seen this behavior already with one or two of the vertices we move. So we will hover vertex 4, so which is right here, and at the northeastern corner of the school, this vertex is already at a good location. We're just going to explore snapping behavior a little bit. Without releasing the mouse button, drag the vertex a small distance in various directions. So, in various directions. As we move south or west along the edge of the feature, we will see the snap tip park's edge appear near to the pointer. So the snap tip tells you that I'm gonna move like this. I don't see a lot. Okay. It didn't say edge here. Appears next to the pointer. So the snap tip tells you that you are within the range or snapping tolerance of an edge in the park's layer. As we move back towards the origin position, we will see the snap tip park's vertices. So vertices. Where is the edge? South or west? South. I cannot see if this thing is here. I cannot move it. I'm gonna use C. And then the shortcut key, I'm gonna zoom in. Z is to zoom in. Alright, and then C is to pan, and then B is for pan and drag. Vertices. Still vertices for me. Okay. And we drag the vertices towards its original position. When we see the park's vertices snap tip, release the mouse button. We use the scroll wheel to zoom on vertex 4. If we do not have a scroll wheel, hold the Z key and then drag the mouse to zoom in and out. If the zoom in too far, the imagery disappears. Press the hold X key and zoom out a little bit. And we will place the pointer on vertex 4 again without releasing the mouse button, and we will drag the vertex a small distance in different direction. So the snapping behavior is the same as before, but the snapping tolerance, which is 10 square pixels by default, now corresponds to a much smaller ground distance. That gives us more control over the exact placement of the vertex. Again, we will drag the vertex back towards its original position when we see the vertex snap tip release the mouse and zoom to the entire diagram. So, and we will save the edits. So yeah, it asked me to save the edits. I'm gonna move a little bit. So once we finish the diagram and save the edits, on the edits vertex toolbar, we will click the finish. So I finished. The edit park is now a selected feature. We can still undo these edits or stop the edit session without saving them, but we should be satisfied with the new park boundary. On the Edit tab in the Manage Edit group, we will click Save. So I'm gonna click Save. Click Yes. And saving the project does not save the data edits. We must click the Save button on the Edit tab to save the changes of the data. So I'm gonna do Save everything here. Update attribute values. We will change the park shape as changed as area. It means that acreage attributes value is no longer correct. We open the parks attribute table at the bottom of the table. We're going to click the Show Selected Records button. And gonna go back to map. So select this. Okay, right click on the open attribute table, and one is selected, which is right here. And confirm that only Pecan Playground is selected. If necessary, we'll scroll down to see, scroll across to see the geometry attributes. So ArcGIS Pro has automatically updated the shape length and shape area fields in the linear shape of the area's projection, but it's our job to maintain the acres attribute. The value stored now is just over 4 acres, 4.1. This is the acreage of the old pre-edited feature. So now going to right click on here and heading to calculate field, and it will be shape.area at acres. And click run and compare the tool and the figure here, and then the new value is written. So the new value run, and the new value is written on the table. It shouldn't be much different from the old value. Although the park was enlarged along its northern boundary, it was narrowed along these 3 parks. At the bottom of the table, click Show All Value button, and on the Edit toolbar, we will clear Selection. Click Save. Go back to Map, clear Selection, and go back here. And then close the park attribute table. We will modify the feature pane. Our edits being saved to the park feature class and are preserved whether we save the project or not. We will save the project because we will keep using it, and we will be back and we will create a new park feature. And how we have a geodatabase. When you start a project file, you know how to create a geodatabase. And next we will do is we will create feature and edit the feature. So see you next time.